For the first compound, we are given OCl2. Because oxygen is the first element in the compound, we know that it will be at the center of the Lewis structure, and that goes for the same for the rest of the compounds. Oxygen has 6 valence electrons, and chlorine has 7. Now we had a single bond, and each atom has a full octet set. Chlorine has 8, and oxygen has 8. This structure has a bent geometry because it has 2 bonds and 2 unshared pairs. Okay, for the second compound, we are given KrF2. Krypton has a full octet set of 8, and fluorine has 7. In order to get a full set for the fluorine atoms, we need to add a single bond to each. Now, because krypton is in the p block, we know that its valence capacity is higher. Therefore, it can hold 10 electrons. We know that the geometry of the structure is linear because it has 2 bonds and 3 unshared pairs. For the third compound, we are given BeH2. Beryllium has 2 valence electrons, and hydrogen has 1. We know that hydrogen can only be connected by a single bond because it only has a capacity of 2 electrons. Therefore, we add a single bond to each side of beryllium to connect the hydrogens. We know that this Lewis structure has a geometry that is linear because it has 2 bonds and 0 unshared pairs. For the fourth compound, we're given SO2. Sulfur, the center atom, has 6 valence electrons, as so does oxygen. In order to give the oxygen atoms a full octet set, we have to give both of them a double bond. By doing so, sulfur is receiving a total of 10 electrons, which is okay because it's in the p block. Therefore, the geometry of the structure is bent because it has 2 bonding sets and 1 unshared pair. For the fifth compound, we are given SO3. Sulfur has 6 valence electrons, and oxygen has 6 as well. For each oxygen to get 8 electrons, a double bond must be allotted to each. By doing so, for the fifth compound, we are given SO3. Sulfur has 6 valence electrons, and oxygen has 6 as well. For each oxygen to get 8 electrons, a double bond must be allotted to each. By doing so, sulfur will be receiving 12 electrons in all, which of course is okay because it is a p block element. It can be determined that the shape of the compound is trigonal planar because it has 3 bonding sets and 0 unshared pairs. For the sixth compound, we're given NF3, nitrogen having 5 electrons, and fluorine has 7. And of course, because fluorine only needs 1 more electron to have a full octet, a single bond is allotted to each fluorine. By doing so, nitrogen is receiving its 8 electrons. It can be determined that the structure is pyramidal because of its 3 bonds and 1 unshared pair. For the last structure, we are given IF3. Iodine and fluorine, of course, each having 7 electrons. we know that fluorine can only receive a single bond to get a full octet. So by doing so, for each of the 3 fluorine, iodine will receive 10 electrons. We know that this structure is T-shaped because it has 3 bonds and 2 unshared pairs. For this problem, we must determine the rate law of 2NO gas plus Cl2 gas yields 2NOCl gas from the given experimental data. In order to do so, we must find the orders or exponents of each given molarity. So for trials 1 and 2, we can see that NO is held constant. Because of this, we can see that Cl2 is doubled and the rate is doubled. Therefore, we can set up the equation 2 to the x equals 2, which of course x can be solved for 1. Now for trials 2 and 3, we can see that Cl2 is held constant, which enables us to see that NO is doubled and the rate is multiplied by 4. Therefore, we can set up the equation 2 to the x equals 4, where, of course, x equals 2. Therefore, now that we have solved for the coefficients, we can determine that the rate law is rate equals K, molarity of NO, squared, molarity of Cl2 to the first. Rate law figured out, we can now determine the rate constant, which is the value of K. We can choose from any trial to plug in the values, so I chose the first trial. By plugging in these values, we can see this equation. When you solve for K, we can see that K equals 180, or 1.80 times 10 squared, 1 over a squared times m.